All right, and let's get into problem number 3 on page 5. What's the rightwards force required to have a 4,000 kilogram crate move with an acceleration of 2 meters per second squared if the coefficient of friction is 0.25? Okay, so let's set up our free body diagram. Okay, so does it say that whether or not we're pushing or pulling on the box? No, it doesn't. So we could just say that we're pushing on the box. And it's going to be, what is the rightwards force required? Okay, so let's say that we're, hey, you know what? Let's say that we're pulling on the box. And the opposing force will be our friction. Is it going to be static or kinetic? Well, we know that's in motion. It's giving us an acceleration over here. So therefore it's kinetic friction. And this is our free body diagram. Okay, and let's pull out all the given information here. What is this 4,000 kilograms telling us? Well, that's going to be the mass of the object, right? And it's saying that we're moving with an acceleration of 2 meters per second squared. Obviously, that's going to be our acceleration. In which direction? If the coefficient of friction is 0.25, all right. And what the question is asking, what is the rightwards force? Okay, so that's our applied force. Okay, and looks like that we pulled out all the given information. So let's set up our two force equations. Alright, and once again, let's say that all the forces going upwards are in the positive direction, and all the forces acting to the right are the positive direction, considering the idea that we are going to be pulling the object to the right. Alright, so all the forces going upwards minus all the forces going downwards is equal to mass times acceleration in the y direction. Is the object moving up or down at all? No. So therefore the acceleration in the y direction is equal to 0. 0 times any number is always equal to 0. And let's do all the forces in the x direction. So what are all the forces going to the right? Minus all the forces going to the left is equal to mass times acceleration in the x direction. We are given an acceleration in the x direction. So therefore we know that we have this information. It's going to be having an acceleration. Once again, the only times that we do say that acceleration in the x direction is 0 is if the object is at rest or if we're moving at a constant velocity. But we are given our acceleration, so therefore we're just going to drop down our information. Another thing that we could actually do here is figure out our force due to gravity. $39,200 newtons. And this is the setup for this problem, and we are done with this.